Hi there, I'm Zach with Preco's die cut division here in Lenexa, Kansas. Today in our Tech Tip series, we're going to talk about the different types of tooling that you can run in your Preco flatbed system, be it steel rule dies, chem-etched dies, Class A male-female dies, even forged shoe dies. A lot of people are pleasantly surprised to find that they can run any one of these different tools in their press with no modifications whatsoever. So first, let's talk about steel rule dies. They're really the bread and butter, kind of the workhorse of flatbed die cutting. Most people are using them. They're simple dies, they're easy to use, they change out quickly, easy to store. You have a lot of options as far as rule goes. You can use 937 rule, 1¼ inch, 1/8 high rule. There's razor rules, different thicknesses of rule. You also have the option, you can do perfing rule, you can do creasing rule, you can do serrated rule for hard materials, things that are difficult to cut. Again, the dies are fairly inexpensive, anywhere from a few $100 up to $1,000 for a more expensive tool like a bolster tool. They really are good dies. A lot of people use them. You'll see we have the locating notches on the die that allows us to use the quick change tooling on the Preco presses. And it truly is a 5-second switchover for these tools. So right here is an example of another type of steel rule die you could have. This is what we would call a bolster tool or feed-through punch setup. The way these work is you actually have hollow punches within the tool that as they cut a slug, that slug will feed up through the tool and can be extracted through the back while you're die cutting. So you get a little bit of your stripping action going on while you're cutting, and it makes it easier to get cleaner parts when you come out of the back of the machine. This one is actually a progressive feed-through punch. So you see here we've got the feed-through punches cutting these little round slugs here, and then when the material indexes forward, they align with the steel rule cut here, which is a through cut. So in essence, we're removing parts, or removing waste parts, and then we're coming up and we're creating a finished part with ID features that have been removed. It is important to point out, though, that with a feed-through punch, generally the material needs to be greater than 7/1000ths thick, and that has to do with the way the bevel is on the feed-through punch. That bevel, the material has to get past that bevel for it to actually pull it up out of the waste matrix. But they're very effective tools and can cut down on a massive amount of labor in a lot of instances. So one thing I want to point out on this tool is you'll see I've actually got 2 different ejection rubbers on it, and that has to do with the difference in the amount of cutting roll from where the feed-through punches are to where the through cut is up top, or the steel rule. The reason for that is because we've got much less rule down where the feed-through punches are as opposed to up top. And so what that does is it causes a differential in pressure as the die comes down and can cause the tool to rock a little bit. Well, that causes excessive make ready. What you can do is you can mix and match your ejection rubbers to compensate for areas where you may have more pressure or less pressure due to either too much or not enough die rule. So down at the bottom, what you're seeing is a very dense, hard ejection rubber, and up top is what I'd classify as a medium. And what that does is that actually causes the tool to come down fairly level. In fact, after that was done on this die, we went from having a lot of make ready up top to keep it cutting nice and square and flat, to having 0 make ready just through a change of ejection rubber. As you move around back, you'll see the parallels and basically the cavity where the parts are ejected through. And you have a few options as the slugs come out the back. Most people will either put a positive air pressure system on it, where you're just simply blowing them out of the die while you're cutting, or they'll put vacuum and collect them that way. Either one is fine. You can even use a combination of the two, where you have positive pressure coming in from one side and vacuum drawing out the other. Here's a few tips for when you're working with steel rule dies on a Preco flatbed die cutter. Should you not have quick change tooling clamps, no big deal. You can just use these holes positioned and they can bolt your die directly into your ram plate. It's very simple, just not quite as fast as the 5-second changeover. Another thing is I always recommend that the locating notches, especially if you have a part that has a unique geometry, be added to both sides of the board. The reason for that is if you have a part that doesn't want to strip going one direction, but maybe the other, it's just simply as simple as flipping the die over, and then you can change the direction as it comes out. And one final tip for steel rule dies, when you're doing make ready, it's okay to use glassine tape on your cutting plate or your make ready sheet, or you can use stainless steel. However, if you decide you want to add make ready to the back of the die, only use stainless steel shim tape. Never use glassine, and certainly don't use packing tape or scotch tape. The reason is packing tape, scotch tape, even glassine, over time the pressure in the back of the rule will burst and your make ready will end up being non-existent. So let's take a moment to talk about chemically etched tooling, or commonly called chem etched tooling. Chem etched tooling is similar to steel rule in the fact that it's relatively cost effective, a few $100s on up depending on the complexity of the die. One of the major advantages of it is its size. You can imagine I can store an awful lot of these tools, especially when I've got small parts. But you might say, well, how do I mount that into my Preco flatbed? Well, the answer is right here. You have a flat aluminum plate, and the dies just simply get taped to the plate. Now, if you're just doing common cuts with no registration, this is a very fast changeover. Again, 5-second tool change out, no big deal. If you're running a registered application though, since the die has to be taped to the plate, you may have to do a small amount of part adjustment to make sure you're back into registration. But again, you're saving a huge amount of space with these dies. Another drawback to them though is the fact that, as you see here, they don't tend to have a very high rule height. Usually on the order of up to about 90 thousandths, maybe 125 thousandths at the max. What that means is you can't really cut very thick materials with it. But on the flip side of that, they have a very high dimensional accuracy on the order of a few 10,000ths of an inch, and they have a very consistent rule height. So that means we can get very consistent and clean kiss cuts on thin liners, and they stay sharp for a long time. Another advantage of chemically etched tooling is just the fact that they can get some pretty amazing detail in the dies. They work really well. It's a photochemical etch process, and then they're machine sharpened. Here's another really cool feature about chemically etched tooling on Preco die cutting equipment. The exact same tool that would be used on a Preco rotary die cutter with a magnetic cylinder can also be used on a Preco flatbed die cutter. It's just a matter of either wrapping the die around the cylinder or attaching it to the flat cutting plate. And remember, the same thing applies when you're using chemically etched tooling. Only use glassine make-ready tape on the back of your make-ready sheet. So here's the type of tooling most people I don't think realize can be run on a Preco die cutter. This is actually a forged die, or sometimes called a shoe die. You'll see these a lot run with clicker presses where they're maybe cutting fabric patterns, leathers, things like that. You can actually run these on a Preco flatbed. You can see this one's been mounted to a mounting board to fit in our 1224 press. It's got the locating notches to utilize the quick change die clamps. Where these come in real handy is they're actually quite effective for heated die applications, because we can heat this die to a high temperature and get very little dimensional warpage on it. They also stay sharp very long. Cost-wise, they're more than a steel rule die, but not terribly. They're actually pretty cost-effective. And with a big beefy rule like this, they last for a long time. Now let's talk about male-female tooling. Most people are pretty surprised to find out that they can put a male-female tool into a Preco flatbed die cutter. And it's actually a pretty easy process, and most Preco flatbeds can accept male-female tooling given you have enough daylight space. And we'll get into that more later on how to mount one. But for right now, let's talk about some of the positives, the pros, and the cons of male-female tooling. And talk about what it is, actually. So a male-female tool is what you see here. It is a manufactured, machined, purpose-built die set. This is only going to cut one part, but it's going to do it very well. When you start getting into male-female tooling, the price tag really goes up for the tooling. But we're talking about people who are cutting millions of the same part, or people that are cutting a part that they have to have 100% slug removal, or they have to have a very good clean edge on their cut. These tools will do it. It's actually pretty amazing at the cuts you get from them. They can eject parts through the bottom of the tool, they can eject slugs through the bottom of the tool, and they cut very cleanly. They also last for millions and millions of cuts. And when they start to wear, you just send them out and have them resharpened. These are the workhorses. These are what are making the commodity parts you see out there. They're also making very high-end medical, electronic. There's just simply some parts that can only be made with male-female tooling. So we talked about massive die life, incredible cut edge, ability to get 100% slug removal or part removal. But another side of the male-female tool is you get very, very high dimensional tolerances out of it. If your part needs to be within, say, a couple thousandths or even a few 10,000ths of an inch, these dies are what you're going to need to look at. They're very well thought out and highly engineered tools.